Webs. Anyhow, welcome. My name is Tobias Dahl. I worked as an animation director on Battlefield 3. And next to me is...
Mikael Hogstrom. I worked as the lead animator.
So, even though we don't have such an exciting title for this presentation, it sounds kind of stiff and it's very late in the day. We will try to make it as enjoyable as possible, so we will have a lot of movies to show. That's always interesting to look at, since it's animation we're going to talk about. So the agenda for the presentation is we're going to look through the kind of high-level goals for the project, art direction. What? And then break those down into what we consider important things for animation to look at. And, of course, we're going to touch upon our new animation technology called ANT, go through the most core animation features. I'm going to discuss a little bit how we look upon the role as an animator or a game animator these days. And then conclusions, and then some fun stuff, and then questions and answers. So, for you who hasn't seen... Oh, I have to say that English is not my main language either.
Not me neither.
So. For you who hasn't played the game or seen the game, we're going to kick off by just showing the single-player trailer that's going to show you guys a lot of what we're going to talk about today. So.
Amadei, hücum. Shame. You come to our country to murder us, yet we are the terrorists.
All call signs listed. We on mission launch. Repeat, we on mission launch.
18 hours ago, I get a call from Homeland Security saying there's a Marine in detention I need to talk to.
Gentlemen, as you know, we're dealing with insurgents crossing over from Iran.
You want us to believe that there's a PLR threat and Solomon's at the head?
You're the quick reaction force, gentlemen. Trusting you to handle this.
The nuke is still out there. Can't just walk away from the threat.
Let's go find our Marines. Get down on the ground! I said get down on the ground!
This is not a trial. You are guilty. I know how your fucking story is.
Yeah, and actually now when I look at this trailer, it was a while ago. Well, it actually was yesterday when I rehearsed the presentation. But one thing that we talk about a lot in games these days is believability. And I don't think that's the same as realism. I think believability is something we could find in looking at real-life references. And when we do stuff like, this is just a marketplace, we have a tendency of using our creative minds and say, okay, I have this great idea of doing a believable marketplace. But, as an artist or as an animator, you sit, I know exactly how a human being moves and so on. But I think that we at DICE and animation department, art department use real-life references a lot to see how things actually are built in real life. It could be roads, for instance. Who is expert in how roads are built in the real world? And I think those are kind of important if you're going to make a believable game. Not roads specifically, but looking at real-life references. One thing that we started to talk about earlier is that we want to have an epic game, and that's also quite obvious in the trailer we just saw, that we have... Don't take photos. That we have possibility to, render large environments and have a long view distance and so on. So here is some early kind of pictures that we found and kind of liked. One thing that we also wanted to do is a physical game, and this is very interesting for us as animators. We wanted to, get the player to feel that he or she is in this environment, that, if something explodes, you should really feel that explosion. It doesn't necessarily, it's all about movement or animation. It could be sound, it could be, a lot of different things. We also wanted to, be able to interact with the world, because we didn't want to, be this character who, just floats around in this world. We wanted the player to kick up doors and, interact with the environment. And the physical part, we can directly take from the overall direction for the game, or the art direction for the game, and put it in our animation direction. So that was pretty easy. And I would say when I do an animation direction for a project, I really would like to keep it simple and as few bullets as possible. And I want the animators to use this as a tool when they give each other feedback. Is this physical enough? It's a pretty, good question to ask yourself when you look upon your animations. One thing that we talked about was urgency. I wanted, in so many games, especially, we can take our multiplayer games, for instance, multiplayer game, that often you're very close to your enemy, and you start shooting, your bullets run out, and then you do a reload, and then, it could be this fancy move, and you open up the lid, and you do these things. But that, didn't do it for us this time. We really wanted the urgency of, oh my God, if I don't do this, I'm going to get killed. And that's something we can apply on many of our animations in the game. And of course, we wanted them to be realistic. We're going to talk more about that later. And the most important thing, or most important goal for me and Mikael, was that we wanted to look better this time than any other shooter out there. So that's what we were set out to do. And now Mikael is going to take over and talk a little bit about how we did it.
All right. So, first of all, then, we traditionally had been working with animation with this kind of, I'm pretty sure that you're familiar with this. This is, a normal blending tree. This is where we come from like the Bad Company series or 1943. Back then, it was really, really hard for us to actually have any sort of control for animators to actually control like the blend times. Each of these states would represent something that would do something to our animation, but we didn't actually have any hands-on. It was hard to get rid of all the glitches. We would hand an animation to an SE, and then maybe 2 weeks later he would put it in the game, and you would then see it, and then it's sort of too late to go in and I need to fix this glitch, but it's really tough because I don't know how to control this tree. So we had to do something to give more power, so to say, to the animators to actually fix their work inside the game. So we started looking around for another solution. We had Frostbite 2 coming up, and we really wanted something on the animation side that actually, was also to the power of Frostbite 2. So we looked at like natural motion, a few other solutions, but in the end, we kind of, we ended up inside of EA, and then we found this software that the sports teams were using that was called Ant. So I know it's like a buzzword that we've been throwing out there, like the Ant engine and the FIFA and all that, but what is Ant really? For us, I would say Ant is like an empty shell or an empty glass, if you would. It's not actually anything. It's just something that, would actually take your animation and show the skeleton in the game. Like, it would show poses in the game. So, but what is great about Ant is that we all can contribute to it. So, if like this picture here, it's like DICE is putting stuff in Ant, Danger Close, SSX, Need for Speed. But then also, and this is something, that inspired me in Tobias, was the sports games from the start. Like, we really think like that FIFA and NBA, they have the best human realistic motion in any game out there right now. And we started thinking about it, like, so why can't we put that on a soldier? It shouldn't be that different. It's a battlefield or a soccer field. It's not that big of a difference. So, of course, then, I mean, when we started with Ant, that didn't really have anything we wanted. So, I mean, what did we need for BF3? And this also turned into the stuff that we gave back to the community in Ant when we were finished. So, I'm going to touch upon a bit about the the methods that we use to achieve the animation direction that Tobias was talking about earlier. These are maybe not features. I'm going to show you a few features, but they're maybe not features per se. So one thing I want to talk to you about is blending. It's always been like something that we found very hard. Like if you go back to the animation tree I told you about earlier, that's something that we really needed to step up our game in. Seamlessness is something that we talk a lot about in the studio. And this time around, it was mostly about cutscenes, like going from... We made an early decision that we really wanted the player to stay in the game all the time. So the first person should be able to move around when we play the cutscene, and that should also, those cutscenes should originate from gameplay. So we needed that seamlessness. Then we had input-driven animation. I'll talk to you about what that means. Layering, and then real-time feedback. So, starting with blends. So, all right. So you got the animation tree on the left there. That's what we had before, and we actually moved on to something called, well, we call it a state flow or a state machine, and that's the thing in the middle there. It's really simple, but it's extremely powerful. It makes the animators responsible for every blend in the game. So, as you can see there, there's a state called an idle, and then you can go into a run, and then you can go into a prone. But between all of these states, there's a specific blend that an animator can go in and change. So that kind of represents there on the right side there with the curve. So you can actually choose, like, you know, do I want a fast in, slow out, or a slow in, slow out, like you can see there. And this is extremely powerful when you're trying to get stuff like, I'm going to show you a little movie here. So this, I mean, this was really hard for us before, just to get this little transition where a guy is sprinting and then laying down. I mean, it should be the easiest thing in the world, right? But it's not. Like, I would fix that in the blend tree, and then all of a sudden, crouching would look glitchy. And I mean, so Ant really gave us the power to go in and tweak these individual. And yeah, I mean, and then of course, it gave us another thing that we could do, and that's per joint blending. And what I mean with that is that you could define when something should blend before something else. So, for example, a head might blend quicker than the torso, just to, you know, it might be the same animation, but the thing is, in games, everything seems to stop on the same frame, and that's so gamey. Like, you know, you can see that that's where the blend happened, but if you can split it up between joints, all of a sudden you get a motion instead of a blend, which is really interesting. Okay, so seamless or seamlessness. One thing that we found really early was that we have a tradition at DICE that we've been really, really anal about our poses. It's something that, you know, we have to pose match everything, otherwise it will look crap. This time around, since we had a good blending system event, we found that speed is actually more important. We didn't really care about the poses so much. We didn't really pose match that much, actually. But the thing we found out that if you're going from one animation that is sprinting and then going into another animation that is not sprinting, or I mean, if you don't have the speed right between those animations, it would just come to a stop, and that would probably be a worse glitch than a bad blend, because, you know, you see that straight away with the human eye that something is wrong with this character. Why is he running into a wall without hitting anything? And that was a key for us on the seamless part. Then another thing that we gave power to the animators to decide upon was the aligning. So in the single player, for example, you needed, you know, the characters to be at a certain place. So we gave this little tag you can see down there. There's like a sequence playing, and then there's a little tag saying like, align myself to the right position during this time, and do it with this curve. So at 0, I would not be aligned, and at 1, I would then be aligned. So it's pretty simple, but it's really powerful to hand that to an animator that knows this animation. He knows when it's correct to actually align these things. So I'm just going to show you a small movie here. So first you can see the characters moving in. They're actually going from gameplay here into a cutscene, and now they are aligning, and that's an animator actually been sitting there trying to tweak this so it looks as natural as possible. And this, we could only dream of this, like for Bad Company 2. I mean, it would take me weeks to try to tweak that. But it looks, I mean, we're not quite there yet, but I mean, it's still, you know, a lot better than what we had just 2 years ago. All right, so, all right, input-driven animation. It's a bit weirdly worded maybe, but so in this I'm mostly touching upon multiplayer in first person. So in multiplayer there's always this challenge of you have a first person character that is supposed to be snappy, is supposed to be input, like when I press the button, if nothing is happening, you get angry. You just want to, you know, get in there, shoot some people. You don't want to feel like it's sluggish, while on the other hand, you have a third-person persona that you want to display weight on. You don't want it to look like, you know, this paper-thin guy running around in the world. But then again, I mean, if you start doing those things like showing a weight change or something like that, then that might actually, you know, break the gameplay. But gameplay is king in multiplayer. You should never break the gameplay. I get this all over, like, you know. If I change something, I get it back like, you know, 10 minutes later. Like, what have you done? You broke multiplayer. But it doesn't really mean that we're not trying to display weight. So I'm just going to show you like a weight shift on a direction change, for example. So this guy here, I've taken away the. It doesn't start. There we go. Okay, so this guy is just changing direction. Nothing is happening to him. It's just, you know, I mean, the blend looks okay, but I mean, it still looks really, really, really light. So here I just added like a little pose, you know, changing that direction. It's not much, but I mean, it kind of portrays for you as someone who sees this guy maybe just as he turns and then he gets this lean position, and that tells you like, oh, he did something. He changed his weight, even though he doesn't. So just that little thing would, you know, fool you into thinking, you know, I changed my pose. And it also gives a really dynamic kind of, I have no set poses kind of feel to an animation, which is great. You know, that's what you want. And that can also be interrupted as well, so you could sort of, you know, change the direction really quickly and you get different poses. Another thing, like a sprint to stop, for example. There's a guy running, and I'm releasing my button, and he's just doing this little slide. This is nothing that we show in first person. It's just something that, you know, we had a tiny bit amount of time that we could show something, because the inertia is really, like when you come to stop in Battlefield, it happens like on a dime. But we just had a little bit of space to put something in, and we could do that for third person, and, you know, it worked great. So, I mean, it's just that little thing that you can think about to just put in on top of input. All right, input spam. This is our enemy. Like, for animators, this is really bad. But as a multiplayer player, this is what you're going to do when you play the game. Like, you want to avoid bullets. You're going to push that crouch button and then the prone button. You know, just sitting there hammering your buttons. We used to have a lot of problems with this. So here I'm just hammering on the buttons, like, you know, I'm changing positions all the time, like, you know, I'm going from crouch, and then down to prone. But what we could do was to actually find these windows where, you know, the pose was sort of correct for you to go down into prone. So, I mean, if I'm at halfway up, maybe I would play the animation from halfway in if I press the button. So it really, he created this really nice, sometimes I'm just playing half the animation, sometimes I'm starting from the end, and sometimes I'm starting from the start, so it's really, really powerful. Okay, weapon lag. This is something that, probably most first-person shooter has some sort of system to actually display the weight, and this is also feeding back to what Tobias said about, believable things or characters in the world. You want them to show weight. We came up with this spring that, it just doesn't drift. It also overshoots and comes back, so you get this little cell, which means, you don't get this gamey blend feel to it. And that's something that we tried to achieve for a long time, but really didn't, actually manage to do. Just a nice way of displaying a weight on a gun, which is, on a stick, really. All right, so, yeah, and of course, this also ties back to the believability and the weight and all that. So a first-person character with lower body. We did this for Mirror's Edge, a while ago, but we hadn't introduced it into BF3, so it's just a natural thing to get in there. And I mean, it just plants you in the world, really. I mean, I don't want to be a gun floating around in the world. I just want to feel like, I have legs. I mean, they don't do much in the game, but it's just nice to have them there because, they're part of my body. So very small thing, but it's really important for us to get these little details right. All right, so another thing that I'm going to talk to you about is the layering. So this is something, it's quite, everyone knows about layering nowadays. Maya has it, Motion Builder has it, Photoshop has it. So why don't we have it, for like a tool to author animations inside the game? So, well, we do inside Ant. And it's really straightforward. I mean, it's the simplest thing ever. You put, you define a layer and what you want to do with it. So is it an additive layer? Is it a solid layer? Is it something else? I mean, is it a certain amount of joints that you want to do? I'm going to show you an example. So this guy here, it's only one layer. It's only the locomotion playing, so I can't aim, I can't shoot, and I can't reload. So it's just one simple layer with the locomotion. You can see nothing's going on there. And then trying to reload. But then you put another layer on top of it, which is additive, and then, combined with the idle that's going on, that kind of really creates this dynamic thing. And it creates a really interesting set of poses as well. And, I mean, it's just, this would then go to, like, if I'm running, I would only play the aim on the upper body so I don't mess up my legs. But when I'm standing, I can use the hip, I can use the feet, all that. And we actually mocap these poses. That was the weirdest thing I've done. But we actually mocap most things in the game just to get it real. We thought it was a waste of money to get like 2-frame poses mocap, but it actually worked out okay. Another thing, like here, you get the firing going on there. That's another additive layer, and then you have the reload on top of it. So, and I mean, this was crucial for us to manage to handle all the guns in the game, because we had so many. We can't create like a special animation for all the fires. So what we did, we put it on a layer, and then additively play the animation. And if it was a weaker gun, you would just scale back on the force of that layer. So it was really powerful tool for us. All right. Yeah. Again, so I mean, layering, separate upper body, lower body, great. It's also fantastic for animators to be able to prototype these things in a language that an animator would understand. I mean, it's really easy to explain the nature of a layer to an animator. And then, yeah, additive solutions to handle multiple weapon setup. Also crucial for our memory budget, so it's good stuff right there. All right, next is real-time feedback. Okay, so this is the last slide, but for me, Tobias is going to take over it. But it's basically just, iterative process. This is probably the most important thing that we had for animation. I'm just going to show you a quick movie. So, you got a soldier, he's getting up, he's running. Okay, so I'm debugging this. Now I can scrub it back, and I can see those really small, tiny details that, normally someone would come up to me, it's like, oh, it looks crap when he's doing this move because it's glitching with the feet or, the spine pops or something like that. I could quickly load that up into Ant, scrub it along, checking that, and then actually seeing what he's doing. And then I can also fix it, which is, a huge thing. We could just dream of this a few years back, actually, because I would be lucky if I saw that in the game, and I would be even more lucky if I could figure out why he was doing that in the game. So, this was key for us to manage to smooth out all the little glitches and stuff that we had. I lied. That wasn't my last slide. This is I think. But, all these features are really cool. But the coolest thing is that they are actually implemented by the animators. We had minimal interference from SEs. Sorry, any SEs. But it's really about the fast prototyping, getting stuff done there, getting animators excited about putting animations inside the game. It's extremely powerful when they get creative and actually can do your animation work in the game instead of in Maya, for example. And it wasn't disrupted to gameplay, and that was, also a key for us. All right, so yeah, I'm gonna hand it back to Tobias to talk a bit about.
Should we switch?
Yeah, switches. Sure.
So one thing that also fell on the animators was the actual scripting of AI moving from point A to point B. So how did we do that? Well, we needed to develop an easy tool for us to, we couldn't, go in and pick each and every animation that were in there because there were thousands. So we kind of came up with metaphors like, now we are in a combat state, now we're in a relaxed state. I'll actually show you a movie that shows it a little bit easier. So what we did was just, kind of painted out this path that the AI should run along. We call them waypoints. And to these waypoints, we can assign different attributes, like this is a cover waypoint, and you should be in crouch, for instance. So here's an example of movement scripting that actually Mikael did, where your squad is supposed to move to, they're supposed to kick up the door, move along here without getting shot by the sniper on the other side of the building. So with some very simple intuitive logic, we can set out the pacing and the timing of these moves too, so they don't, start in a different timing and so on. And as you can see here, we just picked from a long list. This is sort of like, excuse me, building Lego with animation. It's super powerful, and also, if the animators can do this, you can get really high quality of the animations in the game. So we ended up doing, me and Mika actually ended up doing a lot of this scripting. So that's that. One thing that we also knew that we wanted to do is, of course, animate other objects than characters. Sounds very easy, but it could be pretty complicated sometimes. So here's an example, a guy holding a dinosaur. So, how do we add animation to that? Well, that's pretty, straightforward. But we can also do a little bit more powerful thing like, animating an earthquake, for instance. So here's an example of how we did that. So we had a level designer and level art, build the area where the earthquake occur. And from here, from the game, we can just export all of these, oops, sorry about that. All of these objects to Maya, for instance. I'll play it once again. And then in Maya, we can just split up the mesh, and we can skin all the different objects and so on, and run a simulation of this earthquake. The cool thing is that these trees here and all the vehicles, well, they're not, they're just representatives here. They are actually, placed in the game by level design. Then, of course, we need to hook up this entire thing. So we need to have all the transformations from all the joints driving all of these objects that are placed in this scene, it might look complicated, but it's just time. It took a couple of hours to hook it up. But it's super powerful because now we as animator can drive the transformation of these prefab objects in the world. So if I feed a transformation from animation saying, now this tree needs to move because there's an earthquake coming, well then the in-game physics, of course, react to that animation so the trees shake back and forth. So it's a super powerful tool for us. Yeah, one thing that I got a lot of questions about is some of the cutscenes we knew that were really crucial for the story and so on, and we wanted to have super high quality and very realistic, result on those phases. So we use a technology we call a face forward with the help of EA Capture, which is our own mocap studio up in Vancouver. Yeah, once again, there's nothing more real than reality, and this goes back a little bit to what I talked about, using reference. In this case, we actually scan the actor's head and the diffuse map and bump map and whatnot 60 times every frame. So we got the exact, exactly what they were doing into the game. So here is sort of like a couple of movies describing that process. So the first thing we did was we rehearsed with the actors, of course, so they knew their line. And when we felt comfortable, we asked them to put on these beautiful mocap suits and, record the body data.
You were trapped at the bank.
Sorry about that.
Yeah, we're running out of time.
So,
like we are now.
And also
So
during the
they
body
came
data.
into the city.
No, I don't want sound. So during the capture of the body data, we also had head cameras on them because we wanted to capture the eye direction that they were doing while moving around in this scene. We also recorded a temp VO needed later on to mime on top of when we did the facial capture and the actual VO recording. So when we were done with the body shoot, we placed them in this in these barbershop chairs. And this was actually directly after the body shoot, so that's why they, still have their a fresh memory of the scene that we recorded. And then we put the earpiece in their ear with their VO, temp VO from the body shoot, so they had something to talk on top of. And what we also did was had the director standing with a stick on, looking at the looking at the helmet camera reference for eye direction, and with the stick he had like a ping pong ball on and tried to mimic what he was doing with the eyes during the body shoot. So they were sitting there in a barbershop chair, looking left, right, up and down, and so on. And this is kind of how it looked during that recording.
You were trapped at the bank.
You can also hear the
we're
double
running out of
VO
time.
here.
Like we are now.
So they came into the city. Where was that?
There was a plaza outside. We were with the nuke inside the bank, waiting for Miller and Anvil 3 to get there. I radio them. I need to know when the relief force is coming. They say 3 minutes. We'll be there in 3 minutes.
And the cool thing is that while we were in shooting the facial capture, our cinematography was out on the mocap floor shooting the cameras with, the actors were not there, but, with virtual camera and everything. So it was very efficient workflow, actually, even though it might sound a little complicated. So after a couple of hours of magical computer power, this is kind of the raw data, the kind of result we get out of it. This is just me filming with my iPhone, like the first result we get out of it. And I'm quite stunned by, this is super high detail stuff. It's very, very interesting for me to look at. And, I haven't seen anything more real looking than this. And then the guys in Vancouver helped us out doing their magic and, applied everything to our in-game mesh. All of this, this point cloud data. And, we could tweak the eyes and the eye direction a little bit afterwards and so on. And then we also play a movie as textures instead of, playing one or having one texture. We play we had a media player that played a movie as a texture. So we get all the wrinkles and so on going on in the face. So without further ado, this is kind of the scene.
You were trapped at the bank.
Yeah, and running out of time. like we are now.
So they came into the city. Where was that?
There was a plaza outside. We were with the nuke, inside the back, waiting for Miller and Anvil 3 to get there. I radio them. I need to know when the relief force is coming. They say 3 minutes. We'll be there in 3 minutes.
So, now when we've gone through all of this, I want to kind of end the presentation about talking a bit about the animator's role, which both me and Mikael, we talked about this a lot during the project, and I think working as a game animator today has changed radically. And found this nice animation I did a couple of years ago. This is sort of like encapsulates how we look at a traditional way of working. You sit there with your hand keyed nice animation and you tweak it until you're happy, and then you jump on to the next animation. Kind of separated from game development and so on. But what if you're set out to animate the scene like this, which I think more mimic the way we're working these days? Well, we actually want to kind of put out a bold statement, but I don't think we actually have, any animators at DICE anymore. Well, at least not in a traditional sense. I think, looking at the animator's role these days, I mean, we at least at DICE, animators has the responsibility from, coming up with the idea, film it with an iPhone, and, show it the colleagues and get a sign-off, and then plan the mocap shoots, go up to the mocap studio, capture it, and without touching the data, touching the data as little as possible, because, the actual direction, the actual animation occurs up at the mocap floor, put it into the game, and, make all the blending and everything happening, and, really, bring it from the beginning to the end. And this goes, of course, for a realistic game like Battlefield 3 then. So yeah, that's what I just said. So I have a nice movie that kind of mimics an ordinary week as an animator at DICE.
Boom. Polly.
And this is how it ended up. So it might sound a little bit negative and so on, but I think, we are here to make games and not animation, and I think that's super important, actually. Of course, we still, when we look for people and so on, working as animators at DICE, it's of course very important that, you're a good animator. I mean, we're using the knowledge from the animators to do this kind of, scenes and actions and set pieces that we're making in our game. But I do think, it's very, very interesting because the responsibility has gone from, animating this bouncing ball to actually, the beginning to the end kind of deal, which I think it's, it's challenging, but it's very, very fun. So I think it's more interesting now than ever, and especially at, not to brag, but especially at DICE, since we have this tool that is, content-driven, we can try out things, and we are not in the hands of SEs or planning or anything. We can just, let's stay this evening and try out this new feature, and then the day after we can show it and, maybe get into the game. And I think it's more fun than ever. Talk about fun. Animation bugs are very fun. So we thought we're going to end up showing some of them are bugs and some are just us fooling around. And then we go to Q&A.
definitely.
So, thank you very much. That's all we have. Quick again.
All right, any questions? You, sir?
With all that being said about the role of the animator in computer games changing, I would like to hear what is the work of the director of animation in this kind of.
I don't have any word.
You should repeat the question.
I have to repeat the question. So the question was now with the changing of the animator's role, what's the role of the animation director, right? I think, honestly, I guess I'm responsible. I'm responsible for coming up with the direction and make it so that it really ends up in the game, and also in the end responsible over the quality when people come up to me and have opinions about animation. But like a project like this, I really got my hands dirty. So I wasn't sitting around waiting for stuff. I was really deep involved in actually putting these features into the game. So I guess that's up to each and every company how they want to work. But I do produce a lot of assets basically.
So obviously with the single player portion of the game, you can focus more on just the first-person animations, but when you're dealing with a multiplayer and you have to reconcile both the first-person animations and the third-person animations, it becomes more difficult. Were there any instances where you had incongruities between the first and third, and kind of how did you resolve those, and were there any sacrifices that you made to fidelity of the animation for the sake of gameplay?
All right, so the question is, were there any, was there any difference between the first person and the third person in multiplayer, right?
Yeah. Specifically, were there any changes that you had to make to the animations for the sake of gameplay?
I mean, for animations, I not much. I mean, we'd have different animations in first person and third person. The legs are actually the same. They're entirely the same. I mean, just because we really want to be in control over the reloads and stuff, we make different animations. So I think where we have to cut stuff where our designers comes in and tells us this needs to be quicker and you can't take this long time. And I mean, they're really good at figuring those things out. I mean, we try to hide a bit of that in the game, but I mean, they figure out pretty quickly. So I mean, transitions could be one thing, for example. Really hard to get that right because you don't want to get shot in the head when you're halfway up, but you feel like you're not. So I mean, it's a good question, and I mean, it's really tough. But you need to go in there and play the game. You need to be responsible for these things that you put in there because it is game breaking, and that's what I touched upon before. And you need to understand that as well. So
I think one example, for instance, is when if a PC player has a mouse, which is often the case, he or she can just move the mouse really quickly, and the character spins around 360 or 720 degrees or something. And we were like, should we do an asset for that, or should we just have the player to spin? Why should we make a turning animation? We just look like Charlie Chaplin times 200.
Yeah, and then, but I guess, I mean, you do have your animation price. So we ended up putting an asset in there. And then, I mean, so we catered for if the mouse is going slow, we would play the animation. If he decides to spaz out, then okay, you get the spin, you get what you're paying for, right? So.
Thank you.
Thanks.
Yeah, I was curious how much mocap you used for your first-person animations, and how often.
That's a good question. So how much mocap do we use for first-person? We use very little, actually. We tend to, in cutscenes, record a mocap because we need some reference. But the first thing that we usually do is to take it away. Because, I mean, you can't really work with that camera, and you can't really tell the actor to frame the hands. I mean, he feels really weird. So in multiplayer, we would mocap nothing. And in single player, I guess we would use it as a reference and try to, put stuff on top of it.
I think that was something we learned during Mirror's Edge, that motion capture for first person is not that valuable because if you capture, it's very hard to mock-up what the eyes are perceiving. If you just put a dot on the head, that's not how you look upon the world. So we tend to remove all the mock-up for that. One thing that we found out that is really important is, for instance, keep the horizontal line steady. Because if you do this, that feels really weird. If you look at a movie that does this, then something weird is about to happen. A monster around the corner or something.
And we had one guy that we could always try these things out on. He's getting motion sick, really bad. So if he get motion sick, then okay, push it down a bit. Yeah.
So what kind of problems did you run into implementing legs? I know that there's issues with maybe weird collision or hanging off half of a box where the one leg's floating.
Okay. So I actually didn't run into. Oh, sorry. Yeah, the question. So what problems that we run into with the legs in first person? We rendered the legs on top of the world, so we never get clipping issues. We did get clipping issues with the upper body. That was one thing. So what we did was to actually create a pose that actually pushed back the hip. So you never actually you were not you were never clipping because it looked super strange. I wish I had a picture. It looks horrible, but it works. The other thing was, as a player playing a multiplayer game, your legs is probably least priority, right? So you're not going to run around looking at your legs. So we get around. We get we get away with it a lot.
It feels like your camera was really, really important. Like you're informing the player of their physicality and a lot of what's happening in their peripheral vision. And you didn't talk about it a lot, but what did that process look like? Did you author camera animations per player animation, or was there a state layered on top of all that? How did that process go?
Good question. So the question is about the camera. How much did we incorporate it into every animation, or did we have states for it? So we actually did both. We have procedure layers that would take care of idles and stuff like that, and that's really to the point as well. Like with the poses, you create really different poses by mixing up animations, and same with the camera. You can get extremely interesting results having an idle playing, and then you get the reload. And that's one thing to keep in mind, though, that we're really restricted when it comes to multiplayer to actually move the camera. We get told all the time to tone it down. I can't play this game. It's so annoying. I need to focus on getting my reticule on that guy. But sometimes we get a bit of freedom, like for an LMG reload, for example. It should be heavy, and you need to portray it somehow. So we did both. In the asset and then layering.
Thanks.
We got a few glances at your visual state machine layout tool, and you also said that the animators were responsible for laying out the state machine in the trees for the actors, for the AI characters. I was wondering, I'm sure the actual state machine became phenomenally huge. What sort of methods did you use to actually control it, to understand what was going on inside of it? Did you break parts of the trees up between animators?
Well, shall I be honest?
Be honest.
All right, so I did the whole state machine thing. There was some instances. It was really hard, as you say, to actually find out where, but it's split up really nicely because every state machine lives on its own. So, I can tell someone to go in and tweak something while I'll tweak something else. The problem is that they all connected, right? Because it's the same character, so you need to be sure on what you're doing. I don't know. What was the...
No, I think you answered it pretty good. What we can touch upon a little bit about Ant that we didn't talk about is everything is possible to nest with everything. So we can have a state machine in a state of a state machine. That could be in a state machine. That could be
and then you
layered.
Get told off by an SE and you're way over.
Yeah.
So, yeah.
Machine?
Sorry?
Outplotting and meshing?
No, we have not outsourced any animation so far. No, we haven't.
We find it really hard.
We actually got help from other studios doing some reloads and things for in first person inside EA. Then that's the only outsourcing we did so far.
And also, the animation of your game looked very detailed and looked very good. Okay. Can you tell us what the animation budget for both fourth person and third person?
You mean
the
question was
the memory budget for the game, right? For SP and multiplayer.
Yeah.
Okay, so well, it's actually lower than Bad Company 2. We started out with a memory budget of 22 megs. I then got told you have to put it to 16. I got very angry, but we actually managed to fit all the content into 16 megs for multiplayer. For single player, it was really fluctuating. It depended on the scene, what was going on in that certain time in single player. So it could be, I mean, sometimes it was 10 megs, sometimes it was like 40. So it was, all up and down.
We streamed in and out animation data on single player.
Thank you.
Thanks. Okay.
Well done.
Thank you very much, guys.
Thank you.